All right.
Hi.
So, are we on?
Yep.
Cool. Hey, another episode of Inside Out, and we have a very special guest today from Siemens. Please introduce yourself.
So my name is Gerald Käfer. I'm from Siemens. I'm working in Munich at Siemens Corporate Technology. So it's a corporate department. We are especially dealing with software architecture and platforms.
Okay.
And therefore, for us, Azure is, of course, cloud computing as a whole is for us very interesting.
Okay.
And of course, we have to look to all the providers, and Microsoft Azure looks very promising, and therefore I'm here.
Cool. So let's jump right into that then. I mean, why does Azure look promising? What is it?
Because what I really like at Azure is, as presented last year at BDC, the new architecture where you have these programming models with the worker roles, the web roles, and this scalability architecture. So all the artifacts provided by Azure, they force you to program scalability.
Okay.
And this is very interesting.
Interesting.
Yeah.
So let's talk a little bit about how you guys are actually planning on using Azure. It is a pretty general purpose service.
Yeah.
How are you guys in high level planning on using it?
Okay, so let's say within Siemens, so Siemens is big. Siemens has 430,000 members or employees worldwide.
Wow.
And therefore we have many use cases for that. But especially one, we had one which we identified, and this is the remote service use case.
Okay.
To make it a little bit easier to understand, I want to sketch it a little bit.
Okay, great.
That we say, okay, let's explain remote service as an application. So what we have is, first of all, Siemens, our enterprise network. So within Siemens, you know, as at Microsoft, it's a corporate network, heavily locked down. So we have everything you can think about. So let's say we have firewalls here, firewalls. Then we have proxy server and all these checks you can imagine here. And then we have the customer repository. So within the Siemens network. And then remote service, we have 3 DM sets worldwide, and they provide together a service for, let's say, software update. Then we have event management. Then we have asset management. And event software asset, and another one was what is else asset? Monitoring.
Monitoring, okay.
So, and this is a whole package, and our customers here, they have firewalls. So let's say here the firewalls, and then we have the customer locations. And these customers are typical customers, let's say, of 3 types or 3 categories. This is healthcare, then industry, and then we have energy. And devices here are all devices belonging to that domain. So here, computer tomographs, or healthcare devices.
Okay.
Then here we have in industry, we have automation devices. In energy, all the devices for energy generation and transformation. For example, a growing market segment is windmills.
Okay.
So I just make one. It's not a flower, it should show a windmill. So, and here they are also secured with firewalls. And what we have to achieve is now, let's take our sample. What we first identified as a use case is software update, software distribution. We have to push software packages from this Siemens intranet to DM sets worldwide, and then push it through firewalls to the customer devices and deploy them there.
I see.
And we have to do the same with event management and so on, asset management. And the interesting thing is now that we have to do this worldwide. So we have to do this in Asia, Europe, and in the US.
Okay.
And now this is very promising to look at a technology, or at least first of all to look at cloud computing. Because cloud computing spreads all over the world. You don't care about your resources, you just use them on demand. So geolocation is one reason looking at that. And the reason for that is, of course, cost, or the driver behind this is cost.
Okay. So you don't have to manage your own clusters located all over the world. You'd have to buy or create a new IT department to manage this infrastructure.
Yes, because each of these boxes stand for hardware, people, network, and software.
Absolutely.
Yeah.
And so with Azure, you can just spin up instances and deal with this, and let Microsoft deal with all of the hardware, the people, and the IT kind of costs.
Exactly.
Whereas
so
you guys use us just as a service and pay for computation and
exactly.
storage. So let's talk a little bit about how Azure specifically works in this case. So what exactly, not necessarily exactly, since you're still baking this, but what's Azure's specific role in the DMZ story, right? So it's going to be I see here it's a file server to store. So the updates originate from your network.
Yes.
And then they somehow move across into Azure.
Yeah. So let's say make a cloud of that. This would be the Azure cloud. So, and then what we expect to do is, or what we are doing currently is, to provide an application service here. So, let's say a software delivery service. And this service is geolocated. So at the moment, it's only running in the US data centers, but after BTC timeframe, there should be data centers in other locations. And then what we can do is we can just upload our data once to this service. And of course, there's a high redundancy in the data. So a software package like this may be installed on every machine, and this could be 100,000 machines. So this means we only need to upload this package once here, and then it can be downloaded 100,000 times. So the scale out happens in Azure, and we do not have to care about that.
Excellent.
And if we, at the current, and it depends on your customer, on the number of customers you have and on the customer needs. So for example, if you have many updates for new software releases, then you need much more bandwidth, much more storage, and we only need this for a short time frame, for at least, let's say, 1 or 2 weeks, to buffer that until all these devices have downloaded it.
Excellent.
And in this scenario we have here, we have to take care and buy all the machines for that. We have to handle that and tackle that. And here the Azure deal is that we upload this, and Azure cares about that.
Absolutely. And really your only sort of IT administrative role in the Azure case is to just increase and decrease the number of nodes.
Exactly.
Right? Increase and decrease the amount of computation or storage that you need. And Azure actually is flexible enough to do that.
Exactly.
And who knows, maybe someday purely dynamically. But that's further down the line.
Exactly.
That's the future of this stuff.
Yeah.
Very, very cool. Excellent. So you guys are making good progress, and you're here in Rebin today. You're a partner. You're actually members of what we call the TAP program.
Exactly.
Which stands for basically early adoption.
Yes.
And so you actually saw Azure pretty early on, and you've been providing feedback to the team.
Yeah.
Right? To the developers and architects. And so how is this working for you in your experience?
So let's say, first of all, when we started with that and we got the first information at the BDC and after, even before BDC last year, we identified that use case. So cloud computing pay on demand or pay per use and automatic scaling. And then we received this great Azure story with all the building blocks, so Azure, cloud storage, and especially the .NET Service Bus. So the .NET Services are key components because you have to traverse all this firewall and especially at the customer side, the nets. So
cool.
But, and now the first but has to be mentioned is we got some problem because all these three core components or the major components, so Azure, .NET Services, and storage are not fully integrated.
I see.
So, and what we learned over the DAP is, yeah, we have three different business units working together, and this can be improved. So
sure.
And we saw at this review we are currently attending here that they made even a big progress in that direction.
Oh, absolutely. I mean, and I'm not sure whether or not I can talk about this, but we made it sort of explicitly in how the teams are organized now.
Yeah.
So absolutely, that's great feedback. But there are three kind of really big problems that were distributed across the company, which are now in a singular kind of experience or format. But excellent feedback. What else?
So, what else? For example, the TAP team. So our TAP advisors we have, they did really a great work. So
sure.
I can really say it's an honor to be in this TAP program and that we were voted and allowed to participate here. And of course, it's a hard way. So without these advisors, it's difficult because the information you really have in the documents is not that mature. It's quite clear it's not yet a product. Yeah. Therefore, these people are the glue between the product teams and your use case. And this is really a very good experience.
Excellent. And of course, you help the actual product teams build the right thing. Because like any general purpose operating system, the way that Windows, Azure, and the platform on top of it are going to be used, we don't know all the answers, right?
Yeah.
Right? So it's going to be customers such as yourselves that will say, well, here's something that we want to do, but you don't really do it very well yet. And then we end up doing it very well.
Fully agree, yes.
So you're very important in the TAP as you can imagine. Excellent, man. So Azure should definitely work in your solution, and that's a good way to see Azure being used. I noticed no notion of website, which is nice. I mean, you're using it as a computation service, a storage service, as a distribution service.
Exactly. Cool. So for us, of course, maturity of the environment is very important. Therefore, we start to investigate at early stage what is feasible, and we evaluate this in the industrial sector. So, of course, when we start today, it takes at least 2 to 3 years to make this to a full product because of all these high quality requirements we have.
I see. Now, just real quickly before we wind down, all of these actually could have some sort of experience here. For example, let's say I want to use this service to send information back.
Exactly. Yeah.
So, of course, you would then communicate with Azure. It would then send you one thing to one place, but get things from many places. Yeah. Which is, again, it's the sort of the two-way thing you're going to have going, which is very, very interesting. But without getting further into details, it looks good, man.
Thank you.
So thank you for coming on Channel 9.
Thank you.
And for being a TAP partner.
Great. So thank you all for this doing. And
cool.
Cool.
So I can't wait to see this.
Okay.
In reality.
Yeah, I hope so.
Good.
Really soon.
Bingo.